Question 6a. A proton is accelerated from rest across a potential difference of 2.5 times 10 to the power negative 2 volt. Calculate the final velocity of the proton. So here in this question, you have a proton which is accelerated from rest. At rest means its initial speed is 0. And if the initial speed is 0, initial kinetic energy will also be 0. And then it is accelerated through a potential difference delta V of 2.5 times 10 to the power negative 2 volt. Since proton is a positive charge, this potential difference we take it to be negative because we know a positive charge will go from a point of higher potential to a point of lower potential. So its final potential is smaller than the initial. And if final potential is smaller than the initial potential, delta V, which is V final minus V initial, will come out to be negative. Then we know the charge on proton Q is equal to E, which is 1.602 times 10 to the power negative 19 coulomb. And mass of the proton is 1.67 times 10 to the power negative 27 kilogram. We need to find its final velocity. Now, anytime they give you potential difference and they ask you to find final or initial velocity, we will use work kinetic energy theorem. We know from work kinetic energy theorem, work done is equal to change in kinetic energy. And this change in kinetic energy you can write as final kinetic energy minus initial kinetic energy. Work done can also be written as negative of the change in potential energy. That will be equal to K final minus K initial. Change in potential energy we can write as Q times delta V. Here K initial is 0 as the initial speed is 0. So we are only left with K final. Since we want to find the final velocity, we will use the relationship of kinetic energy and speed. So we write negative Q delta V equals half mv final squared. We want to find what is v final, so we will rearrange the term here. You can either rearrange or use shift solve. So when you rearrange, I will multiply with 2 and divide with m to find v final squared. V final squared will be negative 2q delta v over m, and that will give me v final to be equal to square root negative 2q delta v over m. Now this rule over here is the general rule for finding the final velocity of any charge particle if it is accelerated in a potential difference. So you can directly apply this rule if you know the charge and the mass of the particle involved. Now let's substitute for proton. We get v final equals square root negative 2. Charge on proton is 1.602 times 10 to the power negative 19. Delta V is negative 2.5 times 10 to the power negative 2. Mass of proton is 1.67 times 10 to the power negative 27. The mass and charge of proton are both constant. So when you solve this, you get the final velocity of proton as 2190 meter per second, which you can also write as 2.19 times 10 to the power 3 meter per second. Question 6b. An electron is accelerated from rest across a potential difference of 2.5 times 10 to the power negative 2 volt. Calculate the final velocity of the electron. So here my charge particle now is an electron which is accelerated from rest. So initial speed of electron, which we write as V0, will be 0. Since it is electron, the charge on electron Q is negative E, which will be negative 1.602 times 10 to the power negative 19 coulomb. Mass of electron is 9.11 times 10 to the power negative 31 kilogram. Again, both charge and mass are constant for electron. Potential difference delta V is 2.5 times 10 to the power negative 2 volt. And since electron is a negative charge, the potential difference will be positive because we know any negative charge will go from a point of lower potential to higher potential. So my final potential here is greater than the initial. And if V final is greater than V initial, the difference delta V, which is V final minus V initial, will be greater than 0. So it will be positive. We need to find the final velocity of electron. So let's start with work kinetic energy theorem. Now, as discussed in the problem before, you can directly find this velocity by using the rule V final equals square root negative 2q delta V over m. And if you cannot remember this rule, you can arrive at it by using work kinetic energy theorem, as we are going to do now. So we know from work kinetic energy theorem, work done can be written as change in kinetic energy, which is nothing but final kinetic energy minus initial kinetic energy. Work done is also negative change in potential energy equals K final minus K initial. K initial here is 0 because initial speed is 0. And delta U you can write as negative Q delta V equals K final. Since we want to find the final velocity, we will use the relationship between kinetic energy and velocity. So we get negative Q delta V equals half mv final squared. Now we can rearrange here. We will multiply with 2 and divide with m. So you get V final squared equals negative 2q delta V over m. Or you can rewrite the expression as V final equals square root negative 2q delta V over m. So now let's substitute. We get V final equals square root negative 2. Q is negative 1.602 times 10 to the power negative 19. Delta V is 2.5 times 10 to the power negative 2 over mass of electron 9.11 times 10 to the power negative 31. That gives you V final to be equal to 9.38 times 10 to the power 4 meter per second.